Hello everyone, I'm Daeyeal Lee from University of California, San Diego. Today, I'm going to present concurrent refinement of detailed place and route for an efficient issue automation. First, I'd like to briefly go over the challenges in physical design. With the relentless scaling toward advanced technology nodes, increasingly sophisticated IC fabrication constraints such as fewer routing tracks, higher pin density, and complex design rules bring rapidly increasing design complexity. And this leads to non-trivial challenges for physical design, particularly in the routing stage. The number of remaining design rule violations after place and route has become one of the most crucial metrics for an automatic IC layout solution. Because back-end designers must manually stitch and modify all DRVs through the implementation of ECO at the post-layout stage. In particular, achieving the pin accessibility needed to resolve DRVs is a time-consuming engineering task because it requires iterative manual placement, cell refinement, and rerouting. Therefore, the layout refinement flow is a critical bottleneck in the advanced node IC design process. To tackle the current challenge, we propose Core Issue, a concurrent refinement framework which simultaneously performs incremental detailed placement and detailed routing along with cell replacement at the ECO stage. This is the overview of our proposed Core Issue framework. We formulate a conventional layout refinement process as a constraint satisfaction problem with variables and constraints to integrate refinement steps into a single-step optimization problem by devising a dynamic cell allocation scheme. Core Issue performs placement adjustment, pin length extension, and routing optimization to seek the best quality DRV clean solution while minimizing perturbation of the given layout by utilizing an SMT solver. The first refinement operation is the adjustment of the placement. When the given placement layout does not have feasible routing solutions due to an inaccessible M1 pin, Core Issue adjusts the placement of instances by horizontal vertical shifting, horizontal flipping, and cell swapping. For the second refinement operation, our framework suggests minimum achievable pin length extensions needed to fix DRVs. This enables engineers to adapt alternative master cells that maintain the same functionality while minimizing the magnitude of undesired timing impact on each cell. This is an overall issue flow utilizing our Core Issue framework. Given a cell library and initial detailed PNR result, if there exists any remaining DRVs in the non-overlapping regions, we leave up the region and generate a switchbox representation. Then we generate an SMT code and solve the problem. We iterate these refinement steps until we find a routable solution where there are no remaining DRVs or feasible switchboxes in non-overlapping regions. After the iterations, we apply the DRV clean solutions to the original DEF and generate a revised DEF for the next issue round or publish as the final issue result. We generate a switchbox by extracting the instance, pin, net, and obstacle information from each local window covering DRVs. The right figure visualizes the generated switchbox representation from the left local window with one DRV. We categorize the instances in the refinement region as adjustable, fixed, and clipped instances, and the I/O pins, external pins, and net information are extracted according to the given PNR result. The switchbox has obstacle elements represented in the gray rectangles that should be fixed during the issue operations. We define the grid-based placement and 3D routing graph composed of 4 meta layers. Cell instances and I/O pins are aligned with M1 vertical tracks and gate poly of the standard cell. The external pin of a switchbox is located along the boundary of the switchbox, which corresponds to the pre-routed result. We utilize the relative positioning constraints for the placement problem and adapt grid-based multi-commodity network flow and conditional design rules for the detailed routing formulation. 3 fundamental grid-based design rules are implemented by assuming sub-7 nanometer technologies that are based on EUV lithography. The placement and routing formulations are integrated into a single problem through the dynamic cell allocation. when locations of instances are determined by the placement formulation, the flow capacity variables of each instance's pins are conditionally assigned to the corresponding locations according to the placement status of each instance. Then those capacity variables are dynamically associated with flow variables, and this enables our routing formulations to recognize the feasible sets of routing pins. To honor the given initial detailed PNR solution, we minimize the perturbations made by refinement operations. Core issue simultaneously optimizes these multiple objectives in light of the lexicographic order. We validated our framework by using 4 open source RTL designs with 6 different types of standard cell libraries. As shown in these graphs, we performed 20 iterations of issue routing until the commercial tool is unable to further reduce the number of DRVs along with the following core issue flow. This table summarizes the experimental statistics. Core issue reduces the remaining DRVs after issue routing by 58.6% on average. The reduction of the average total wire length by 0.003% shows that our framework has successfully minimized the wire length. For all benchmark cases, core issue performed 3.3 issue rounds on average with an average runtime of 11.5 hours. These results demonstrate that our framework can further improve the routability with the concurrent cell refinement and routing optimization. This table presents the detailed refinement results of one of the AES benchmark circuits. The total of 5 issue rounds with 42 switch boxes have been performed to resolve 61 out of all 74 DRVs. This figure shows the reduction of DRVs in full chip layouts by multiple issue rounds. The below figure shows an example of refinement operations for the index 38 case. Core issue framework corrected 3 DRVs by adjusting placements and extending I/O pins of adjustable instances. In summary, we proposed a novel concurrent refinement framework for the automated issue flow. Our framework provides simultaneous and perturbation-minimized refinements of detailed placement, detailed routing, and cell-optimized layout solutions by leaping up and refining a local window to address the DRVs during the issue stage. And we have demonstrated that our framework successfully resolved the remaining DRVs across a range of benchmark circuits with no adverse effect on the total routed wire length. That's all about my presentation. Thank you for listening.